We'll start in 1 minute. Today we'll continue with the problems in section 7.5, solving applications with rational expressions. Okay, this problem, number 5, Lizette can mow the lawn in 3 hours, and Barbara can mow the lawn in 2 hours. Find the amount of time it takes both of them to mow the lawn together. Okay, this is a work problem, so equations have the form rate times time equals 1. So rate times time equals 1. 1 represents the job or the task that is being accomplished. From the first part of the first sentence, Lizette can mow the lawn in 3 hours. So for Lizette, we'll write down an equation that has the form rate times time equals 1. For Lizette's rate, I'm going to write R sub L, and in 3 hours, Lizette can mow 1 lawn. In the second part of the first sentence, Barbara can mow the lawn in 2 hours. So for Barbara, the rate times time equals 1 equation. Barbara's rate, R sub B times 2 hours equals 1. And we're supposed to find the amount of time it takes both of them to mow the lawn together. Okay, so when they work together, the rate is Lizette's rate plus Barbara's rate. And let's let capital T represent the amount of time it takes them working together. So I'll label what T is. T is the number of hours it takes both of them working together to mow the lawn. All right, so now we proceed to the next step. So what we do next is similar to what we've been doing on the other problems.
Divide 3 for this Is that when you take the line 3 from itself and then line 1?
Okay, yeah, so we're going to solve each of those equations for the rate. So the top equation, Lizette's rate times 3 hours equals 1 lawn mowed. So Lizette's rate is 1/3. So what that means is Lizette can mow 1/3 of the lawn per hour. That's her hourly rate. Barb's rate is 1/2 of the lawn per hour. When they work together, for now, all we can say is that the rate is 1/T. The goal is to determine what the value of T is. So let's just summarize the procedure up to this point. We're given information about work. We write down a rate times time equals 1 equation for Lizette. A rate times time equals 1 equation for Barbara. And a rate times time equals 1 equation for when they work together. And in that one, we assign a variable T to represent the amount of time it takes them working together to mow 1 lawn. Then we solve each of those equations for the rates. Lizette's rate is 1/3. 1/3 of the lawn can be mowed per hour. Barbara's rate is 1/2 of a lawn per hour. And when they work together, we're representing the rate as 1/T. Okay, so now what? What's the next step?
You take their rate and apply it to that equation.
Yeah, in this equation, when they work together, Lizette's rate plus Barbara's rate equals 1/T. We're going to replace Lizette's rate with 1/3, and we're going to replace Barb's rate with 1/2. So we'll get an equation whose only variable is T. So Lizette's rate plus Barb's rate equals 1/T. So now we have an equation whose only variable is T, and now we can solve for T. This is an equation with rational expressions. The variable that we want to solve for is in the denominator. So the procedure is to find the least common denominator. The 3 denominators are 3, 2, and T. So the least common denominator is 6 times T. You can, if it helps, think of 6T as 6T/1, so that you remember that 6T is in the numerator. Then we multiply the least common denominator by every term on both sides of the equation. That will clear the denominators for us. So multiply every term on both sides by 6T/1. So 6T/1 times 1/3 plus 6T/1 times 1/2 equals 6T/1 times 1/T. Hey, simplify each of those. I'll take this, I'll write a little more detail than is necessary. 6T/1 times 1/3 is 6T/3. 6T/1 times 1/2 is 6T/2. And 6T/1 times 1/T is 6T/T. And then write each of the fractions in lowest terms. 6t divided by 3 is 2t. 6t divided by 2 is 3t. And 6t divided by t is 6. And then 2t plus 3t is 5t. And then lastly, divide both sides by 5. So we get t equals 6/5. So 6/5 hours. So that's 1 hour and 12 minutes. So that's how long it takes them. So I'm sort of ran out of space, but up here I'll write it. It takes them 6/5 of an hour, or 6/5 hours to mow the lawn together. Okay, let's look at the next problem. This one says it took Lance a total of 2 hours to ride his bike 12 miles and run 6 miles. Lance's running rate was 10 miles per hour slower than his biking rate. Find Lance's running rate. Hey, this is uniform motion. So we're thinking in terms of rate times time equals distance. Okay, well, Lance is doing two things over a period of 2 hours. During the 2 hours, he's riding his bike a distance of 12 miles and running a distance of 6 miles. And as we would expect, the running rate is slower than the biking rate, and it's slower by 10 miles per hour. So find Lance's running rate. Okay, we want to find the run rate or the running rate. So we'll pick a variable to represent the run rate measured in miles per hour. So I'll just pick X for the running rate. And then when he rides his bike, the rate is 10 miles per hour faster, right? The running rate is 10 miles per hour slower than the biking rate. So I guess I should write bike rate, but you know what I mean? So if the running rate is X miles per hour, what's the bike rate?
X minus 10.
Well, the bike rate is faster.
X plus 10.
Yeah, X plus 10 miles per hour. Yeah, the run rate is 10 miles per hour slower than the bike rate. Okay, at this point, the only thing we know about time is the total amount of time it took to ride the bike 12 miles and run 6 miles. The total amount of time is 2 hours. So we're not told specifically how much time it took to ride the bike 12 miles or the specific amount of time it took to run 6 miles. We're just told that the total amount of time to bike 12 miles and run 6 miles is 2 hours. So we have to keep that in mind. But at this stage, we're ready to write equations, each having the form rate times time equals distance. Okay, so the running equation and then the biking equation. Okay, rate times time equals distance. First, for running. Well, we're representing the rate by x miles per hour. So rate times time, well, we don't know the exact amount of time, so we have to use a variable representation. So I'll use T sub r for the amount of time it took to run 6 miles. So rate times time equals distance. The biking equation, the rate when biking is x plus 10 miles per hour. So x plus 10. And we don't know specifically how much time was spent biking 12 miles. So we'll use a variable representation for that, T sub b, for the time it took to ride the bike 12 miles. The goal is to get an equation whose only variable is x. And then once we have that equation, we can solve for x. But we still have some intermediate work to do. What do we do next? At the moment, we have two equations. Each of them has the variable x, but also each one of them has a variable for time. Well, we don't want an equation with a variable for time. So somehow we're going to have to get rid of T sub r and T sub b without violating any logic in the process. So how do we do that?
You add the two equations together.
Well, that wouldn't, if we added the two equations as they are written, we still wouldn't get rid of TR and TB. Okay, the hint is in the first part of the first sentence. What does it say? Well, let's read the whole sentence. It's the whole sentence. Yeah, the first sentence says it took Lance a total of 2 hours to ride his bike 12 miles and run 6 miles. So in terms of our variable assignments, what does that mean?
Both are equal to 2 hours.
What's that?
Both are equal to 2 hours.
Okay, so how do we use the, yeah, you're correct, but we need to be more specific. In an equation, how do we say that the sum of the amounts of time is 2 hours?
Miles is greater than 6 miles.
Yeah, so T sub r is the amount of time running. we add that to t sub b, that's the amount of time biking, and it adds up to 2. So yeah, I got a correct answer online. T sub r plus T sub b equals 2, right? Okay, now we're just a couple of steps away from getting an equation whose only variable is x. Now what? Okay, well, this equation, x times T sub r equals 6, we're going to solve for T sub r by dividing both sides by 6. So divide both sides by x is what I meant. So T sub r is equal to 6 divided by x. And then the other equation, x plus 10 times T sub b equals 12, we're going to solve that for T sub b by dividing both sides by the binomial x plus 10. So T sub b is 12 divided by x plus 10. Okay, now we can write an equation whose only variable is x. So in this equation, T sub r plus T sub b equals 2, we're going to replace T sub r with 6 over x. So we'll get 6 over x plus, and then we're going to replace T sub b with 12 over x plus 10. So we get 12 over x plus 10. And the sum is 2. Okay, now we have an equation whose only variable is x. This is an equation with rational expressions. The variable that we want to solve for appears in 2 different denominators. So the technique that we use, that we've been discussing for the last couple of days, we find the least common denominator, the least common multiple of the denominators, and then we'll clear the denominators by multiplying every term on both sides by the least common denominator. Okay, the least common denominator is x times x plus 10. You can think of that as x times x plus 10 over 1. Then multiply every term on both sides by the least common denominator. And that will clear the denominators. Or, to be more mathematically correct, it will reduce every denominator to a factor of 1. Okay, so multiply every term on both sides by x times x plus 10 over 1. So x times x plus 10 over 1 times 6 over x plus x times x plus 10 over 1 times 12 over x plus 10. And then on the right-hand side, x times x plus 10 times 2. Okay, we're going to get cancellations. That's the whole purpose for multiplying by the least common denominator. So in this first product, x divided by x cancels. In the second product, the binomial x plus 10 divided by x plus 10, those cancel. So let's write down what we have. X plus 10 times 6 is 6x plus 60. And then plus x times 12, we write that as plus 12x. On the right-hand side, x times x plus 10 times 2. Well, we have x times 2 is 2x squared. And then plus x times 10 times 2 is plus 20x. In the next step, we'll do a few things at once. So on the left-hand side, we have a total of 18x. 6x plus 12x is 18x. So we're going to subtract 18x from both sides and also subtract 60 from both sides. So when we subtract 18x from both sides and subtract 60 from both sides, we'll get 0 equals 2x squared plus 2x minus 60. Since we're solving an equation, and the greatest common factor of the terms is 2, we can divide every term on both sides of the equation by 2. 0 divided by 2 is 0. And then divide every term on the left-hand side by 2, we get x squared plus 1x minus 30. And this factors really nicely, x squared plus x minus 30. One factor is x plus 6. The other one is x minus 5. You can verify that just by looking. Positive 6 times negative 5 is negative 30. And positive 6x minus 5x is 1x. This equation has two solutions. X equals negative 6 and x equals positive 5. But for our purposes, in the word problem, the positive solution is the only one that makes sense. So that's the running rate. So we found that the running rate, Lance's running rate is 5 miles per hour. Okay, let's move on to the next page. This one says, working together, Edward and Brent can rake a yard in 6 hours. Edward takes 2 times longer to rake the yard by himself than Brent. Find the amount of time it would take Brent to rake the yard by himself. Okay, so for Brent and then Edward, and then afterwards together, we'll write equations that have the form rate times time equals 1, because this is a work problem. So work problems have equations of the form rate times time equals 1. We're supposed to find the amount of time it would take Brent to rake the yard by himself. So Brent works at a certain rate. We're supposed to find the amount of time it takes him to rake 1 yard by himself. So let's use capital T to represent the amount of time it takes Brent to rake 1 yard by himself. So T is the hours it takes Brent to rake the yard by himself. Okay, what should we write down for Edward? Well, Edward works at a certain rate, so I'll represent Edward's rate by R sub E. So what about Edward's time?
Times it by 2.
Times what by 2?
The T.
Yeah. Yeah, we're told that Edward takes 2 times longer to rake the yard by himself than Brent. So we're using T to represent the amount of time it takes Brent, T hours. So Edward takes twice as long. So for Edward's time, we write 2 times T. So for Edward, we have rate times time equals 1. And then when they work together,
RB plus RE times T equals 1.
RB plus RE times
T.
Well, how much time does it take them when they work together?
All 6.
Yeah, 6 hours. When they work together, the amount of time is 6 hours. So when they work together, Brent's rate plus Edward's rate, we multiply that quantity by 6, and the product is 1. So when they work together, we have rate times time equals 1. Okay, the goal is to solve for T. That means we need an equation whose only variable is T. So what we do next is the same sort of thing that we've done a few times already. Okay, at the moment, we don't have a single equation whose only variable is T. We do have 3 equations, each having the form rate times time equals 1. So what do we do next? Okay, a hint is we did the same kind of thing in the very first problem that we solved today, number 5. What did we do? Well, what's that?
We divided the time by 1.
We're going to solve each of the 3 equations for the rates. So Brent's rate times T is equal to 1. So Brent's rate, when we solve for Brent's rate, we get 1 over T. We divided both sides by T. Edward's rate, we can solve for Edward's rate if we divide both sides by 2T. So Edward's rate is 1 over 2T. And then we have a third equation. Brent's rate plus Edwards' rate times 6 is 1. So if we divide both sides by 6, we get Brent's rate plus Edwards' rate equals 1/6. And now we can write an equation whose only variable is t. So in other words, we're combining the results of these three equations. Brent's rate is 1 over t. We're adding that to Edwards' rate, but Edwards' rate is 1 over 2t. And the sum of Brent's rate and Edwards' rate is 1 over 6. So now we have an equation whose only variable is t. So note that they all represent, each of the terms represents the same kind of thing. It's Brent's rate plus Edwards' rate equals the rate when they work together. The variable that we want to solve for is in the denominator of two of the terms. So our method is to find the least common denominator. The least common multiple of t, 2t, and 6 is 6t. Okay, so we multiply every term on both sides by 6t. To avoid confusing numerators with denominators, you can think of 6t as 6t over 1, if that helps. So multiply every term on both sides by 6t over 1. So 6t over 1 times 1 over t plus 6t over 1 times 1 over 2t equals 6t over 1 times 1 over 6. Okay, 6t over 1 times 1 over t. The t's cancel, so we're just left with 6. 6t over 1 times 1 over 2t. Well, t divided by t is 1, and 6 divided by 2 is not 3. I mean, 6 plus 3. And then on the right-hand side, 6t over 1 times 1 over 6. 6 divided by 6 is 1, so we're left with t. And 6 plus 3 is 9. So t equals 9. To summarize our result, we would say Brent takes 9 hours to rake a yard by himself. Okay, the next problem. Corinne rode her bike 5 miles uphill and then back. So 5 miles uphill and then 5 miles back. The rate going downhill was 20 miles per hour faster than the rate going uphill. And it took 20 minutes longer to go uphill than downhill. So we want to find the uphill rate. Okay, this is a uniform motion problem. So equations will have the form rate times time equals distance. So it looks like we need two of those equations. One, when Corinne rode her bike uphill, we'll come up with a rate times time equals distance for going uphill, and then a rate times time equals distance on the ride back downhill. Okay, and the rate going downhill was 20 miles per hour faster than the rate going uphill. And it took 20 minutes longer to go uphill than downhill. Find the uphill rate. Okay, so my tendency is, after reading the problem a couple of times, identify what it is I'm supposed to find, and then pick a variable to represent that quantity. So find the uphill rate. All right, so the uphill rate, I'll just pick X miles per hour for the uphill rate. Well, with the variable assignment for the uphill rate and the information in the problem, we can also write something for the downhill rate. So what's the downhill rate?
X plus 20.
Yeah, X plus 20 miles per hour. Because we're told in the second sentence, the rate going downhill was 20 miles per hour faster than the rate going uphill. Okay. Okay, so Corinne rode her bike a distance of 5 miles uphill and then a distance of 5 miles back downhill. We're not told specifically how long it took to ride 5 miles uphill, and then we're not told how much time it took to ride 5 miles downhill. But we can still write the equations. Rate times time equals distance. So let's write the uphill equation. And then the downhill equation. That will get us started anyway. Okay, rate times time equals distance. So going uphill, we're using X to represent the rate in miles per hour. We don't know specifically how much time it was, so we'll use T sub U to represent the amount of time it took to ride the bike a distance of 5 miles uphill. So we have rate times time equals distance. Okay, then going downhill, the rate was X plus 20 miles per hour. And the amount of time we don't know specifically, so we'll use T sub D to represent the amount of time it took to ride 5 miles downhill. Okay, so we need an equation whose only variable is X. That means we need another equation that relates the times. The time it took to bike 5 miles uphill compared to the time it took to ride 5 miles downhill. Well, we're given information in the problem about that. So what information are we given about the times?
Took 20 minutes longer to go uphill than downhill.
Yes, it took 20 minutes longer to go uphill than downhill. Okay, so how does T sub U relate to T sub D? T sub U represents the amount of time it took to go uphill. T sub D represents the amount of time it took to go downhill. And in the third sentence, we're told it took 20 minutes longer to go uphill than downhill. So we can say T sub U, the amount of time it took to go uphill, 5 miles uphill, is greater than the amount of time it took to go 5 miles downhill. It's greater by 20 minutes. Okay, so we have a couple of things to do. We do want to convert this to an equation, but we want it to have the appropriate units. So we're measuring rates in miles per hour. And the difference in time is given in minutes. So we're going to have to do one of two things. We're going to have to convert miles per hour to miles per minutes and leave the difference in time in minutes, or if we leave the rates measured in miles per hour, we're going to have to convert 20 minutes to a certain number of hours. So you can do it either way, but we can't use mixed units. We can't use miles per hour with minutes. Okay, what fraction of an hour is 20 minutes?
A third.
1/3. Yeah, 60 minutes in 1 hour. So 20 minutes is 1/3 of an hour. So that's what I would do. The amount of time it took to go 5 miles uphill is greater than the amount of time it took to go 5 miles downhill by 1/3 of an hour. Okay, let's convert this to an equation. If I subtract the smaller number from the larger number, it's equal to 1/3 of an hour. So the amount of time it took to go 5 miles uphill minus the amount of time it took to go 5 miles downhill equals 1/3 of an hour. Okay, now we can focus on getting an equation whose only variable is x. So we're going to do the same sort of thing that we've been doing. We'll solve this equation for time. So x times t sub u equals 5. Divide both sides by x, we get t sub u equals 5 over x. Solve this equation for time. Divide both sides by x plus 20. And we get t sub d equals 5 divided by x plus 20. Okay, now these three equations, the information from these three equations will be combined and we'll have one equation whose only variable is x. So in this one, t sub u minus t sub d equals 1/3. Replace t sub u with 5 over x. From that, we're subtracting t sub d. We replace t sub d with 5 over x plus 20. And 5 over x minus 5 over x plus 20 equals 1/3. Okay, now we have an equation with rational expressions, but it has the variable x that we want to solve for. So we find the least common denominator. The least common multiple of the denominators x plus 20, and 3 is 3x times the binomial x plus 20 over 1. Okay, we're out of time. So next, just multiply every term on both sides by the least common denominator and then solve the equation. Okay, that's all for today. So go ahead and sign in for attendance.